So if you're like me, you bought a mini CNC machine and really didn't know how to use it, so it just sat around, and maybe even assembled it and tried to turn it on and it just wasn't cutting properly. Well, I'm going to show you how to do that. I had to figure out a lot of this stuff on my own by going through a bunch of YouTube videos. It was a pain in the ass, so I'm going to try and condense it all into one short video, short as it can be, that you guys can watch and figure out how to run your 3018 CNC Pro like a pro. Alright, so the machine I have here is a CNOS upgraded 3018 Pro. It's the cheapest one you can buy on Amazon about 2 years ago. The listing is now discontinued, but I'm going to show you how to get this thing up and running as fast as possible because there was a lot of issues with it. The main thing you're going to encounter is the spindle you get with it is this one, and it's just not powerful enough to really get what you're trying to do. I think it is I think it's a 557 or a 550, but the upgraded one that I have here is a McDowell 775 spindle motor. And then I also got hold downs with it. You're going to need hold downs if you lost them, like I did. You can order more from Amazon. The next thing you have to do is get a 24 volt power supply. If you have a cheap power supply, like I did, it came out with a 14 volt. The motor would not reach maximum speed, so you were pretty much fucked in that regard. So you got to get a 24 volt power supply. I only got one that's 5 amps and takes 120 watts, so it should be good there. The next thing is, once you actually get it up and running, it's going to be jumping all around, so you're going to have to bolt it down to a table or have a lot of weight because it's going to be hitting the material, and then this will be bouncing all around. So make sure to square the frame and then bolt it to something like I have here, and you'll get good results like this. The next thing is the program you're going to get comes on a flash drive like this, and it really looks like shit. It's called Candle. Let's see if I have it here. So this is Candle, and you can use this interface and upload your G file, your G code here, and you can have it run to your machine there. You got a USB plugged into your computer, USB plugged in back here, mini USB. You then have to hit the power button on here to hear that turn on. And then if you have it configured with your program, so you go to settings, and you'll see COM5, that's your USB port. And there might be another one, COM3. Say OK. You can hear it made a sound over there. And let's see if we can turn it on. So there we go. So you would load your program into this by going File, Open, then you pick your, should open up a dialog here. Alright, so when you're setting up your first project, this is one that I did. This one needs a little work, but I'll show you how to do it a little bit better than that. So you want to get your piece here and have your clamps. And you want to make sure to have the clamp configuration they have. So you can then put it on your board. And there's no real set way to do this. You just kind of find a way to lock it in on all corners. And what I like to do is take a ruler or a measuring device and measure from the side of my edge here to the board, so that way I know it's straight all the way across. That's what I've been doing. So you take a ruler, you just measure from the edge of the table here to your piece. If you got a square piece, you know, you can just do it that way. And then you can lock in the rest of these. I'll go ahead and do that, and then I'll speed it up for you guys. And then now that I have my machine connected here, turn it back on in the back here, and I can move it to the left and right. Well, let me refocus my camera. All right, so now we're going to walk through the process. So we have Candle open, and my recommendation is not to use this software just because it's not very good. We could load a program here, but the better thing to do is to get a program called it's OpenBuilds Control, and there's so I can explain this a little better now that I'm back at my normal computer and I'm not out in the shed. So I have OpenBuilds Control, and this is what it says right here. This is what you're going to use to run your G-code. So you're going to put this on your computer or whatever that's communicating with your CNC machine, and this is going to actually run your G-code jobs. And you need to create the G-code with OpenBuilds Cam, which is also free. You just access it in your browser. So you would go to openbuilds.com, you go here, and then this is where you would set everything up. So we're going to select our controller. We have a generic GRBL because we just bought this cheap machine off Amazon. Select machine. I don't think I selected one. We're just going to leave that blank for right now. What we need to do is turn our spindle on. We don't have any of this other stuff because we're not turning on any plasma or lasers. We're just turning on a spindle. Our x-axis length and our y-axis length, they should be somewhere usually on the listing. I believe they should have the length. I think ours is 400 on the y and 200 on the x, maybe. I can't remember, but it'll be different for your machine, so you'd have to measure it or find it out yourself from the listing. And we don't really need any of this stuff. I'm not going to mess with any of that. Power speed scale 0 to 1000, I would leave that as it is. So we're going to say save. And then here, this is a pretty cool program. So we can type some text here. We're going to say hello. So we create that, and you can see we have some text there. So now that we have this text, we can actually click here and move it around. And these are coordinates on our CNC machine. So this is our piece, you know, imagine that. And then our CNC is going to go around this line. So once we have the text that we want to create, this is actually pretty small. So I'm going to grab the arrow over here, highlight everything. I think I can do that, maybe not. We'll grab the scale. We'll click on that and we'll go scale. I think that's close to 7 inches. So yeah, so that's about as far as I can do on my machine, because I think I have about 10 inches. So 7 inches right there. That looks pretty good. After we have that, we click. We're gonna circle all these, and then we need to add a toolpath. So we say there, create new operation, and we can leave that as is. Type of cut, so we need to select what type of cut. I usually go for pocket on this type of thing because that'll just go around and leave a nice pocket where everything is. CNC vector, we'll just play around. We're going to do vector path inside, and we need to select what our Endmill is. You should be able to find this out on the listing for whatever you're buying. Whatever Endmill you're purchasing, it should say the diameter of it. So I know mine is 3.175 diameter. I usually do 0.5 millimeter per pass. Oh, sorry. 0.5, enter, 0.5. Safe Z height 10, that's a little high, but whatever. Feed rate, for my machine, I was keeping it around 300. And for the plunge, I put it at 30 just so it'd be slower. That's how fast it's going to go down. And we can see advanced settings down here. I'm not exactly familiar with a lot of these settings, so I don't mess with them. We can go ahead and apply and preview our toolpath. So you can see here that this is where we're going to travel, and that might cause some problems for you if you want these letters to be more individualized. So that's path outside. Let's try a different one. Let's go add, create new operation. Let's try path inside. Did I mess this up last time? I thought I left it 3.75. Alright, let's apply.
And see, that looks a little better because it's not going to the outside of the line, it's going to the inside of it, and our letters are a little smaller. And then let's try one more time, create new path, and this time we're going to do a pocket, and I think that should be like right on the line. Oh no, that's going to pocket out the entire letter. So step over, I think that is how much it's going to step over the last current pass. We'll leave that where it is. Cut depth, I usually go about 2 millimeters when I'm doing engravings like this, because that just looks good to me. Feed rate, we're going to keep that the same. Again, advanced settings, I usually just leave that as it is. So now we have that, and you can see the green is where it is going to pocket out. And this is going to take the longest, but now that we have that, we click the generate G code. And you can see here that this is where our machine is going to run. There we go. We have all those lines. That's where it's going to make plunges, and then it's going to run along the red lines with our 3.175 millimeter end mill until it's got a step over of 40% all around. So yeah, we got that. We can save our G code now, and we can name this whatever we want. I'm going to name this good file.g code. So we will save that, and it just downloads to your downloads folder, and then I can go to OpenBuilds. There we go. OpenBuilds Control, allow access. All right, so we open it up. We get our advertisement. We can then, I don't have any machine connected right now, but we open our G code here, and we'll just go to our download folder. There, and we'll have our good file. And so here now we have our we can use this to run. We have our G code file. Here is all the points that we're going to go to, and we can run this. It says it's going to take 2 hours and 30 minutes. So yeah, you can keep that in mind, that the pocket is definitely going to take a lot longer than just going to the inside or outside of the line. But yeah, that took me a long time to figure out, so I just wanted to make sure that people had a better way to figure it out than I did.
OpenBuilds Cam, which is web-based. So basically you would go to openbuilds.com. They have the one you use in the browser to make a file, and then after that you would download it and use it here. And so we can connect to our machine by clicking on our, I got a fake Arduino on COM3, so that's this machine. We then hit connect. We heard a little sound from our machine, so we know it's connected. We see all of our stuff down here. And so now if I go to tool on and route it on, we can spin up, and we'll turn that off. So the most important things to know on here are your GRBL settings, GRBL settings, and you can set these through codes by giving commands to your machine. But the problem with that is it's a pain in the ass. So if you go through OpenBuilds Control, they have this nice program, and you can go through here and change your settings there. So the important settings down here are maximum spindle speed. I usually keep that at about 1,000. From my understanding, it's more of a percentage, so it's just going to use the maximum spindle speed all the time, which is what I would recommend for 3018. And down here, you can see your steps. If you have a problem with overstepping or something like that, you would come in here and mess around with that. Now, these are your rates.
Alright, so when I'm watching the footage back, I can see my explanation is a little bit complicated. So what I'm doing right now is just going back over it as I'm editing this video. And basically what I'm trying to say with the maximum rate here is this is the maximum amount of speed that that your machine is going to move in that axis. So if you have a feed rate of 500 when you were setting up your toolpath like we did in the previous 5 minutes, and it's 500 up here, and then your fastest speed rate down here is 300, you're not going to go 500, you're going to go 300. It's only going to go as fast as you set it here. So if you want to keep yourself safe, I would recommend updating these here just in case you don't want it to move so fast, just to make that clear. All right.
But after you have all that set, you can go here and we'll open a G-code file, and I have some ready. So I'll go here and click on that. And so this loads my G-code. So this is just the letters 14406. It's a little address thing I'm making. And we can go to the G-code editor here, and this is the actual code that makes up all the positions. So the first thing we need to do when we want to run this project, after we have it loaded, we'll go back to our 3D view. This little blue thing right here, that is where it believes our machine actually is. It's where this thinks it is. So we're gonna set it back to 0. So I'm going to go here, set it to 1 inch, and then we'll move on the x-axis. I need to go further on the y-axis towards the camera, or away from the camera, right there, and then I'll start coming down on the z-axis. Move it to 0.001 inches. And so that's going to be my 0 position. It's really close to that clamp, but I actually do have about 3 millimeters there, maybe about 2 millimeters. And I know that this lettering that I have is going to be about 7 inches by 2. So 7 inches should be around here, and then 2 inches should be somewhere in there. And if you look at the bottom of my screen, there's a little bit of an offset there. And you can zoom in. I don't have a mouse right now, I just have a touchpad, so I can't really do much for you. But I could zoom in and show you that. But so, since this is still off 0, what we need to do here is say set 0. And that is going to return everything to 0 here. And we can run our job. Let me just grab a pair of safety glasses. So I zoomed in a little bit, and now we can see our spindle is at 0, and we're ready to run this job. I would definitely recommend hearing protection because it is super loud. So we're just going to go ahead and run it now.
Yeah, I'll just give a little voiceover here for what went on. It took about an hour and 30 minutes. I think it actually took about an hour and 15, so it was faster. I sped it up. As you can see, it went through like 2 different cycles, so it like carved out the first pattern, and then it kind of left the letters a little disjointed, and then it went through a second time and, you know, finished them out, which it's doing now. So yeah, that was really interesting to see. I hadn't really used a CNC much before. I operate a lot of equipment, but never really a CNC machine. So it was very fun to get this thing up and running, and I made this because it was very confusing for the beginner. And I hope this makes it a little better for people who are out there trying to figure it out.
All right, so the thing is finally done. I think that's looking pretty good. So to return it back to 0, we're just going to go ahead and say go to 0, and yeah, we'll do working coordinates. All right, so now that we got all that done, I'm going to pull it off and show it to the camera. And if you did have a bunch of these to do, what I would recommend doing is, you see these Sharpie marks, you just take a Sharpie and mark out where you got it, and every piece was. So yeah, that's about how it looks. And then what I'm going to do is just take a hand rasp real quick. That looks pretty good.
Alright, thank you for watching. This channel is mostly about doing game development tutorials with the Godot engine, but I also like to just do random tutorials on stuff that I found fun. So here's a CNC video for you guys, and please check out my channel, and if this helped you out, subscribe, like, and share the video. Thank you.